Hi everyone, Zach here, and welcome to lesson 62 in this series on developing a survival game. In this video, we'll begin working on our day-night cycle. This will take 3 videos. In this video, we'll be setting up the calculations for our game time. This video and this series have been brought to you by Patreon sponsors, and you too can help support this channel. And all you have to do is hit that like button down below. And if you've not already, make sure to hit the subscribe icon as well and turn on all notifications so you know when new videos and new live streams are announced. Alright, open up your project and we'll make a start. Welcome back to the engine, everybody, and in today's video we're going to start our day-night cycle. In the next video we're going to add in our star cube map and change it over so at night we transition from our daytime to our nighttime. Now in the last video I moved the sun to test our clouds, which again are hidden right now because we defaulted to a clear sunny day. So I'm just going to set this back to my morning sun, which is 0, -45, 0 for our rotation. Again, if I consider this the start of my island, I want that to the right, which I'm considering east, north, south, west, which will come up later on when we put our compass system into effect as well. So to start this, I want to make some changes. I've noticed that for some reason the tessellation on max tessellation has gone away. We are going to set this back to, if you had this issue or for some reason I skipped it, don't think I did. I remember talking about this with you guys. Set this to 2,000. And again, we're using a really large number. Actually, I'm gonna set it at 20,000. We're using a really large number here, but we're controlling for what we're actually doing inside the layers themselves. And we're gonna change our water material just slightly. And this is to reflect the fact that we are using atmosphere in a different way. Now, as I do that, of course, it's gonna recompile all the shaders. So I'm not gonna pause during this part like I normally do, because I'm just gonna go straight into the water. And we're gonna pop this open. And yeah, I need to rebuild lighting. So because we are now using a different atmosphere system, we are going to allow for cloud fogging. We are going to compute per pixel. Again, if this is too intense on your system, you can get rid of that one. And we have no velocity to really worry about. Yeah, it's moving, but we're not going to care about that. And we are going to scroll down and we're going to use with water because it's water and it just activates some stuff in the system that makes it a bit better. We're going to go down to forward shading and we're going to use high quality reflections and planar reflections, or how do you say that? And then our tessellation is as is. Our pixel normal offset is as is. Again, remember, if you're having that weird line show up where you can see the shift in the Fresnel or the reflection, your pixel normal offset is not set. And that will also affect the color of the water as well. So I'm just going to apply this. I'm going to save it. It's going to recompile the shaders yet again. It's fine. I'd rather it recompile the shaders. And I'm not going to pause because, well, we're not really worrying about that right now. What I'm going to do though is go to core and I'm going to create, no, I'm not going to create it. We already have a folder for it. I'm going to pop open my survival game mode here. I'm just going to pin this in the window up here because we're going to come back to that but towards the end of this video. What I am going to do, however, is create a game state. Now, if you've done my RTS tutorial series, this is very similar to what we did there. I am going to, however, use the date time structure properly. So we're going to search for game state and we want the game state base. So select that. And I'm just going to name this BP_game state. Of course, it's saving, which means I'm going to have to rename it because I can get a chance to finish typing in the name. There we go. And go ahead and pop that open. We're going to switch over to our event graph. And our event graph, we are going to use the tick and the begin play. Just going to give ourselves some space though, so I'm going to move the tick down. The first thing I am going to do is I'm going to create a DateTime structure, sorry. And instead of making one from scratch, we're going to use one built into Epic. So I'm just going to call this game DateTime. It will be of a DateTime structure. And I'm going to put this in a category called GameTime subcategory master. And we're going to set this. Now, something I have found that's really weird, and I'm not sure if this is a me thing or a project thing or what have you, is that the time is off by an hour from whatever you put in here. So I'm going to start here. This is our year. I'm going to give us a fantasy year, a sci-fi year, I guess. Whatever you want to call it. A year that clearly it isn't. I'm going to do 2134. And I'm going to set it to be when I originally prepped this version of it out, which is in April on the 14th. I have a thing for doing date time structures on the 14th of months. And I'm going to set this to, say, 09 6:30 in the morning. That's roughly where the sun is located, with 0 seconds, and I can't ever get this to change. So if I do that, it just goes back to 1. So it's how much it's increasing by, I guess. Yeah, so we've now set our default times. Of course, we need to then take this information and set that for our game time. So our game time is a float that is going to include our hours, minutes, and seconds. So I'm going to take this date time structure here, I'm going to get it, and then I'm going to break it. With it broken, and I can't hide unconnected pins in this version, unfortunately. I don't know what's going on with that. I'm going to leave it as is just for a moment. I'm going to then create a new variable called GameTime, which is of type float, and it's going to go into that master category, and I'm going to set that on event begin play. Event. I know I just missaid that word, but whatever. And the way I'm going to do that is I'm going to add floats together. So I'm going to do float plus float, add pin, and we're going to take our hour and allow it to convert over. Our minute, we are going to convert it, and then we're going to move it and break it. And for this one, what we're going to do is we are going to divide it by 60. So we're getting a proportion out of 60. When this is 60 minutes, this then becomes a 1, and it updates it. Well, I'll update an hour. So that gives us what we need for our minutes. And similarly, our seconds are going to be put into that same point after the hour. So the way this float works is the whole number is the hour. The decimal is the minutes and seconds added together. So the way we're going to do our minutes, or sorry, our seconds is very similar. We're going to take our seconds, convert it over. So I just Control W to those two nodes. And instead of dividing by 60, we're going to divide by the number of seconds in an hour, which is 3,600. So that is now taking our default game time and setting, or our default game time via the structure, and setting our game time for a float. So this sets initial game time, and then we're going to store our days, months, and years as well. And so we're going to take these two nodes, the date time structure, or the game date time structure, and the break. And actually, we can hide this one a little bit, because the first 3 nodes that pop up are the 3 nodes that we care about. And we're going to promote these each to a variable. So we have year, which will go into our game time subcategory calendar. I'm just hopeful I spelled that right, but you've heard me say that I don't care about spelling anymore. As long as you know what I'm trying to spell. We're going to do the same for our month. And notice that it already has a name for us. Just going to pop that into the correct category of calendar, or subcategory of calendar, and then do the same for our day. So all we're doing is we are taking our default values and placing them in, well, variables within our game state. Now, why are we using game state to do this? Well, game state is persistent across every instance of the game. So that means that this will always exist. That's the only reason we're doing this. We could create an actor for it, but then we'd have to put it in the world. We'd have to find ways to reference it. It's easier to reference it this way. I'm just also setting a comment to remind me what this is doing. So we're setting the initial date variables. Next, what we're going to do is we're going to implement a time on our game clock. So what we're going to do for that is we are going to set our game time. So we're going to take game time, we're going to set it here on the tick, and we're going to do some maths between here on our delta seconds and our set. And we're also going, well, let's take care of that first, actually. So we're going to create a function that will collapse down to a pure function. We're not going to do this in a function library like we did in the RTS tutorials. We're going to take the delta time, so the delta seconds, and we are going to divide it by a variable that we'll create in just a moment called GameSpeed. We are going to add this into our game time. So we're going to take, it's basically like what we did health. When we take the health, we minus from it, and then we set health to whatever that result is. We're doing the same thing here. We're taking the game time, we're getting what it currently is, which is why we have to set it here. And then we're adding something into it and then resetting the value. So game time goes right there. There we go. In fact, actually, I'm going to leave this outside because I'm going to collapse it without it being in there. So I'm going to move it to the far left for a moment. I will put a rerouting because I will have a reroute in the collapsed version of this. Oh, sorry, no, don't plug that into there. I skipped a step. I skipped a very, 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 very important step, which is we need to get the modular and the whole number. So fortunately, Unreal has this built into the C++. It is not in the, in the blueprint. It is not in the C++ version, and that is division, whole, and remainder. We are going to divide, so our divisor, I think I said dividend when I meant divisor in the last video, is 24. The remainder goes into our game time because that is our minutes and seconds and hours. When we divide by 24, that's our day. So what we're going to do for day here is we're going to pull off our return value and create a new variable called day counter. This will either be 0 or 1. So it doesn't do anything particularly useful except for go, I'm either 0 or I'm 1. If I'm 1, please update everything else. And we're going to set that there, put a little reroute in here so it's a little bit easier to read. And now we need to take care of this missing value that I talked about a moment ago called GameSpeed. Now, just like the tutorial series, I'm going to pick a particular GameSpeed, and that is 150. So I'm going to just promote this to a float. This float will be called GameSpeed. And I'll explain what 150 means in just a second after I compile and set that value. Again, this is just going to go to the side, and I'm going to put this in my game time and a subcategory called settings. There we go. So what does 150 mean? 150 means that roughly that 1 hour in real world time is equivalent to 1 day. And I'm just going to make a quick comment. I did this in the last in the ARTS tutorial series, but it was hard for people to see, so I'm going to do it here as well. So change default value to change game speed, and the settings are default of 1 is 1 real second equals 1 game hour. That's really fast, so I meant to hit Control Enter before I continued. A default of 60 is 1 real second equals 1 game minute. A default of 3.6K, so 3600, is real time. The way to think about it is we're dividing by 36 there. A default of 2.5 is 1 real minute equals 1 day. And the default that we're using, I gotta remember to hit Shift Enter. So a default of 150, 1 real hour equals 1 day. So that's what the system is. I'm just going to zoom in for a moment for those of you who couldn't read it when it was zoomed out. There you go. That's what our settings are doing. So with this, that's where the first time I hit C went. We're taking every real hour is 1 game day. Let's take these 3 nodes. Let's collapse this down to a function. This function will be our calculate. Really? You're going to let me type? Calculate game time, and my input pins will be our delta time, our B or our Bravo will be our game speed, and our game time will be current game time. Our remainder will be game time or game time out or updated game time, whatever makes it easier for you to know what we're looking at. And then our return value for the integer is our day count. This is a pure function. We aren't setting anything in here. The setting is happening here. All we're doing here is calculating out a value. So it's a pure function for that reason. Pop open this function and just line things up a bit nicer and neater. So it's just a little bit easier to read what's going on. I'm gonna put a second reroute in, I guess, because yeah, I think again, lining these things up to make it easier to read is useful. So we're taking the delta time, we're dividing it by game speed. We're taking the result of that division and we're adding in our current game time. We're dividing that by 24 because there's 24 hours in a day. But if you want a different length to your day, you're going to change this number. We are taking that remainder and putting that into our game time. If this is a whole number, so it's 1, so in other words, this equals 24, then we're updating our day counter. All right, just going to start cleaning this up just a tiny bit. There we go. And move that a bit closer. So that is really the crux of what we need to do. Of course, now we need to set all of our structures to match what we have. So we're going to create a long series of functions that will just pass out this information. We'll create it here, then collapse it down. So we're going to take our game time. We are going to multiply it by 3600. And the reason why we're doing that is we want to take from this the game seconds. So if we multiply this by 360, we're reversing what we've done up here. And of course, then we're gonna need to make sure we remove anything that is greater than 1 minute. So we're gonna do a division, whole, and remainder. And because there are 60 seconds in a minute, well, we divide this by 60. Anything that remains is our seconds. So we're gonna just create Actually, we're going to take our remainder. We're going to do floor. So what a floor is doing is that we're rounding our value down. And it's going down to the next lowest integer. So as you can see in the tooltip there, negative 1.6. The next lowest integer is negative 2. Remember, when you're doing negative numbers, the larger, quote unquote, the absolute number, the smaller the actual value. If it's positive 1.6, it becomes 1. We want to go down to the nearest second. We are then going to promote that to a variable that's called second, or seconds, or whatever you want to call it. And I'm going to put it in a category called GameTime, subcategory clock, just like in the RTS tutorial series again. And we're going to just plug that into there. If I can get the sets to go into each other, thank you. We are going to take the return value here, and we're going to do another division, whole and remainder. Because now we have everything in seconds, we now divided it by 60. Everything is now in minutes. So we're going to convert that for our dividend, and we're going to again divide by 60 because there are 60 minutes in an hour. Hopefully the logic of that is making some sense. That is not what I wanted to do. So we're going to again take the floor of this because we want the closest thing to the hour that we're at. We don't want it to round up. We don't want it halfway through, say 6 o'clock, saying going, it's 7. No, it's still 6. It's like misreading a clock, an analog clock, because it says it's 6:45 and the hour hand's closer to the 7 than it is the 6. We want to avoid misreading our analog clock, so to speak. We're going to promote this to a variable. This will be minute. Again, it's going to go into our clock settings there. Plug that into there, move that up there. And then we're going to come off of here again. And I'm not sure why I did that. You've seen it do it to me all the time before, though, so whatever. We're going to do another division, whole and remainder. And this time what we're going to do is we are going to, again, divide by 60 because we're looking for the number of minutes in an hour. So again, we're looking for the number of seconds in a minute, number of minutes in an hour. And again, we're kind of doing number of minutes in an hour again. And we're going to do just the remainder, and we're going to do a floor. Actually, technically, this is just what are the seconds, and the number of seconds in minutes, and the number of minutes an hour. Sorry about that. I was slightly misspeaking when I walk through each of those 3 nodes they're doing. And this will go into clock, plug that into there. And what we're going to do now is we're just going to, when we collapse it to a function, pass this information out. To just give me a little bit of a cheat space, what I'm going to do is I'm going to take my day and just put day right here for a moment. I'm going to take everything from my game time times 360, or sorry, times 3600 seconds all the way to my setting of the hour, and I'm going to collapse this down to a function called set calendar. All right, just line that back up. Let's move this back over here. And what we're going to do is pop open this new function. We're going to put that there. And then we're going to put a return node in. With our return node, what we're going to do is we are going to pass out this information in the order of hours, minutes, and seconds. And the reason for that order is just it's the order in which it shows up in the DateTime structure so that we don't have crossing pins. So we're going to pass out hour, minute. I'm going to rename this as hours because we're passing out the number of hours. We're passing out the number of minutes, and we're passing out the number of seconds once I get that into the correct spot. So we're doing it in the reverse order that we had plugged them in or set them. Now I can compile and save this. I don't know why I hit save because it is auto set to compile whenever save whenever I compile, but forces of habits die hard. So for our day, what we're going to do is we're going to take our current day and we are going to add to it our day counter. Remember, our day counter fluctuates between 0 and 1. So this is that, oh, please update everything I mentioned earlier. So take your day counter, add that in, and let's just move the pins underneath so it's a bit tighter and easier to read. Again, remember additive principles. It doesn't really matter which order these go in. We are then going to take this value and we are going to check if it's less than our days and months, which is a structure or a function, sorry, not a structure, that is part of our date time settings. It's already built into the engine. Of course, you could use your own number if you want to change the number of months in a day. Sorry, number of months in a day, number of days in a month, or if you wanted to create your own structure with your own calendar, you could do that as well. We're going to put a branch in. This condition will plug into there, and let's finish setting up this condition. Off this value here, I'm going to do days in month. And all we're going to do is we're going to check what year it is. So we have our year. And we have our month, and we're going to plug those into there. If we are true, if we are greater than the days at this point, then there are in that month. So if it's, February and this is day 30, well, one, we should never get there. But if that did somehow happen, we'd want at this point to reset our day to 1. So make sure that says 1 and not 0. And then we'd want to increase our month by 1. So what we can do is take our month, and we could technically increment it, but I don't like doing it that way. What I want to do instead is do a int plus int. I'm going to leave the the bottom value as 1, and I'm going to plug month back in for the top value. Now, again, this is very important. If this is not true, then we need to bypass this because we still need to check other things. So again, if for some reason your clock isn't working, start here and make sure that you didn't ignore my comment about passing around on the false. So you need to come around and come off the false. So we're going to put a branch in off the true line. Again, as I talked about in one of the intro prep videos, all this true is doing is saying run everything on this line. It doesn't know when the ending curly bracket is that you would get in C++ code. It doesn't know, oh, I only need to do this. If it only did the first thing, then we would have to have another branch for this. So we need to tell it, hey, this is our else condition. So we're coming off the false, and if this is not true, else if, then bypass all this and do our next check. So again, if this isn't working for you, double check that you haven't done this. There are a lot of people in the RTS tutorial series that struggled and then would go, oh yeah, I missed coming off the false on one of these. And you're gonna do that for almost all the branches we're about to do. Next we wanna check is the month. Technically, I guess if the day isn't updating, you could skip the month, but I think just having them all in here just makes you less likely to make a mistake. So we're gonna take our month and we're gonna check, is our month greater than 12? Unless your calendar has more than 12 months, in which case you need to make a special version of this thing, then if it's greater than 12, we should be resetting our month to 1 and updating our year. So let's take our month, we're gonna set it to 1, just like we did day here, and we're gonna increment or increase year in a similar fashion to this. Again, you could actually increment it, but I'm going to do my preferred method, which technically is a little less efficient, of int plus int. We're adding 1 in, we're adding in 1 to year. There we go. And then this is the end of that function, but to make life a little bit easier, what we're gonna do is we are going to set our date time structure here just for a moment. We're gonna put a reroute in, and we're gonna plug into the false. Again, we need to go around. So in theory, if you did wanna skip this first false going into the second check, you still have to go around, you still have to do a false here, you still have to come off this false and come into where we have this plugged in on the second false instead. So in other words, what we're currently doing is checking, hey, are we updating the day? If we're not, are we updating the year? Which really should never happen. You should only update the year if the day is updated, but again, I like being pedantic and having the extra step in. And instead you could do, are we updating the day? No? Well then just update the overall calendar in general for time. That's what's gonna happen here. Let's take all these nodes from our day through to our reroute on right after the year, collapse it down to a function, and this is set calendar. Sorry, I called the last one set calendar by accident. I'm gonna rename this as set game clock. I don't know why I did that. This is set calendar. All right, let's start bringing these nodes back closer to each other. And let's pop open our set calendar here. And I swear I just saw a execute line fly somewhere for a moment. I'm seeing things apparently. So we'll come off this reroute here and do our return node. And again, we're gonna pass out in the order of year, month, day. So the reverse of what we've done, because that's the order in which it shows up on the structure. So year, month, day. And at this moment, I really need to do something out of my own morbid curiosity, because I think it took me an hour in the RTS tutorial series to go through all of this, and that was 27 minutes. I've gotten better at some of my timings. Okay, so what we could do, and what we're not gonna do, but it is a viable option, it is another method of doing this, is we get the date time structure and we set members. Oh, okay. Apparently you can't set members in the structure, so never mind that idea. Usually with structures you can set members. So we're gonna go with my original plan of make date time. We're gonna expand this out, and I think you only need up to seconds. You don't ever need to worry about milliseconds. And I think in the C++ version, there's other options as well. So we're just gonna come off year, go into year, come off month, go into month, come off day, go into day. You know what I'm going to say for the next 3. But now what I'm gonna say, and you probably already know, is reroute time. Let's make it pretty. So I'm just gonna select the reroutes, the 2 setters. Oh, I did that badly. And just hit Q. That did not work the way I wanted it to work. That did not also work the way I wanted it to work. There we go. That's what I wanted it to do. There we go. So now we're setting our date time structure. we can do is now test this out. So all for debugging purposes is we're going to do a print string. So will let me pull off of here, print string, and off our print, because I do want a bit of space to actually make this work, or to give myself some room. We're going to do an append, and we need up to E. So A, B, C, D, E. In B, I'm going to put a colon. In D, I'm going to put a colon. So I'm actually only going to do time, by the way, if you haven't worked out what's going on here. I'm going to get my DateTime structure. I'm going to break it. I am going to expand it. And it's going to go, of course, my hours, followed by my minutes, followed by my seconds. Now, what I could also do is break this just for a moment. I could create a second append. Actually, I would need 3 technically for this to work. We're going to leave the second one there for a moment. Just going to move this down a little bit. And I'm going to put a third pin in there. Put a Shift Enter for B. This will be my C. This will be my A. So this is time down here, and we're going to do calendar on the top. And we need, again, this will be day. This will be slash. This will be month, because we're using the non-US version of it, because the US version of DateTime makes 0 sense. There'll be another slash, and then again to E for year. So smallest, medium, large. Instead of medium, small, large. Again, what's going on, US? All right, now let's go to our game mode and make sure that our game state right here, second one on the list, is set to our BP game state. Go ahead and compile, save, Shift S, and hit play. Let's make sure the time is actually showing up, and it is increasing. So I just went from 30 to 31 to 32. Our lightning's still active, and to have a little bit of fun, we can just speed this up. Actually, I'm going to make this go at really insane speeds. I'm going to die before the year changes, so I'm probably going to need to unplug the timers for that. Yeah, I am definitely going to die before the day changes. So we probably are going to want to use that time, and I'll talk about those calculations in a video or two. And here are those calculations for how we are going to change our timers for our hunger and stamina system. We're not going to do that in this section, but that is something we need to take care of. All right, given that this is already just over 30 minutes, and this is just for debugging, so I'm going to comment that out, I think it makes more sense to pause here because we have a material to make. We need to explore why that material works the way it does, and we have to import a cube map as well to get our system fully working, and then we have to also attach this into our weather system. So I'm going to pause, I'm going to finish here, and in the next video, as I mentioned already, we're going to add the cube map. Well, we're going to actually add the sun rotation for our day-night cycle, and now we have our time and our calendar for our day-night cycle. We're going to do the rotation for our light. We're going to talk about the differences between 4.26 and 4.2, or anything before 4.26, in particular the skylight, and why that little checkbox matters so very much for what we're doing, and how to get around that if you're in earlier versions and you're using a different approach, what your options are. That said, as always, this series has been brought to you by my Patreon sponsors like Rian, Connor, Hanas, and 1Volt10. If you've enjoyed setting up your game clock, make sure to hit that like button down below. It really does help this channel out. It lets me know I'm bringing you content you appreciate. It increases our YouTube analytics so that people who might not know about this series are more likely to see it. And if you want to be here when we actually add in the sun rotation and have our transition into our starry night, then that lightning, dude, then make sure to hit the subscribe and notify bell. That said, I look forward to seeing you in the next tutorial, and I hope that you have a wonderful day.